Max loves attention as well.
They're not going to turn it down, but just different vibes. All right.
Yeah.
Let's get going with what we need to do today. So we're going to practice with our solving stuff. We're going to get through some equations, all that jazz. So we are starting with this one, our 16 to the x plus 9, 4 to the x minus 2. There it is.
But since I have a dog, she always sniffs my stuff because Aurora has probably laid against it or something.
Oh yeah, the dogs always sniff me a lot too because my cats.
It's adorable because she, after she was done, she gave like a lick of approval to my hand.
Love it. All right. So we've done something like this before. We got a couple of ways we can work with this one. What can we do for the 16 to the x plus 9 and 4 to the x minus 2? We can make them have the same base. Like, we don't have to solve this with logs. We can solve this exponentially. Because I can rewrite that 16 as 4 squared to the x plus 9. When we have two sets of powers, we multiply those together. I'm going to rewrite that too. It just looks weird. There we go. Still looks weird, but that's okay. So we can rewrite 16 as 4 squared. Our equation's still the same now. And we can go through this and solve. Because once we have those bases the same, how do we get to a solution? Put the powers equal to each other. So we can take, and I'm going to do this multiplication at the same time. My 2 times x and 2 times 9 gives me 18. X minus 2. 6. Now what do? Minus x. And we can subtract 18 on both sides too. That's going to give us our x all alone on this side equals, the x's cancel out, and we have negative 2 minus 18, giving us a negative 20. Is that a valid solution or no?
Yes.
Yeah, totally is. I can have x be negative, it can go in powers, I can have negative exponents, not a problem. So that is a valid solution. So that was kind of a easy one to start the day. Questions on that one? The one on the right is kind of icky. So when we have different bases, because I can't make 2 or 3 be the other base. I can't make them be 2 squared, make 3. So we are going to have to use log properties to be able to solve this one on the right. So log is kind of like an operation, like adding something to both sides, subtracting something to both sides, squaring both sides, square rooting both sides. I can log both sides. And when we have different bases, we're going to have to log both sides. Or you have to switch it into log form, and it's just going to look a hot mess. But it's kind of easiest to just go log both sides. And you can use, I would recommend either common log or natural log. Because calculator buttons. We're going to want a decimal at the end so we can check stuff. You can use whatever base you want, but I recommend 10 and E, just because ease of use. So I'm going to use the natural log because it's shorter. It's 2 letters instead of 3. Genuinely the only reason I'm choosing it. So I can write this as ln of 2 to the x plus 7 equals ln of 3 to the 2x. So all I'm doing is I'm going to take the log of both sides.
But that's not log base.
That is log base E.
Why?
I was like, you can use any log you want. It doesn't really matter. As long as you pick the same one and do the same thing to both sides. Genuinely, the only reason I picked ln instead of log base 10 is because log has 3 letters and ln has 2. Sure. If you need a way to make a choice, that gives you an option because they are equally valid. There is no reason to choose between them. There's a choice. The benefit of doing this, logging both sides, is now I can use log properties. Because I have x's in my exponent. Ew. And I really want those x's out of the exponent. So we can use our power property. I can take my exponent down and make it a coefficient. I can take this exponent down and make a coefficient using our power property. So I can rewrite this one as our x plus 7 ln of 2. Yes, dear? No. Okay. That's called, I'm super good at counting and handed out exactly the right number of papers. So we can take those powers down and make them be coefficients or have them be in front and multiply. We can get rid of the x's in the exponent and get them down into kind of like the main line. And this looks kind of gross. Kind of a lot gross. We got to remember, ln of 3, that's a number. ln of 2, that's a number. It's a gross number, but I can type ln of 3 into the calculator. I can type ln of 2 in the calculator. I get answers. They're just not nice. So we can still solve this the way we've solved all kinds of other things before. If it was x plus 7 times 2 and 2x times 3. Doing the same kind of thing, it's just that these are gross. So what we're going to do on the left is we're going to distribute that. We need to multiply out my x plus 7 times that ln of 2. I'm going to give myself a little barrier over here because this one's being a little wide on this next step. So we're going to have x times ln of 2 plus 7 ln of 2 equals our 2x ln of 3. So now we have no more parentheses anywhere. We love that. We're trying to get down to an x equals. So that means I want to get my x's on the same side of the equation. We're going to subtract that guy from both sides. So we're going to have our 7 natural log of 2 equals 2x ln of 3 minus x ln of 2. Ew. It's gross. But the reason we want our x's on the same side of the equal sign is now I can take that out like a GCF and leave this hot mess of numbers. So this is just a number. It's a gross number, 7 ln of 2. I could type that in the calculator. And on this right-hand piece, I can take an x out as a GCF here. That would leave us with 2 ln of 3. Again, a number. I could type it in the calculator. Minus ln of 2.
Could we condense them? Or no?
You can condense it if you want. You don't have to,
Okay.
but you can. You would need to take that 2 up to be a power on the 3 again. But you could do it. We're going to type in the calculator anyway, so it's not a huge deal. And then I have here a number equals x times a really gross number. This is just a number. If it was a 2, we would divide. It is 2 ln of 3 minus ln of 2. We're going to divide. So we can set this up for an answer as a fraction, 7 ln of 2, and we divide it by 2 ln of 3 minus ln of 2. I would 100% take that answer. If you want to condense the denominator down, take our 2 out to be 3, so it's 3 squared, minus 2, so it would be 9 over 2. Totally valid. Again, absolutely fine option. If you want to condense it, go for it. Not gonna hurt you. I'm gonna grab my calculator. Because what we really want to do is we want to get our decimal answer here. Write it down because otherwise I forget. Boop. Ooh, calculator accurate. There we go. Calculator. With these, if we're trying to get our decimal answer, we're just going to type the whole sucker in and call it good. So we got our fractions. We're going to use our fraction button. And I can get 7 natural log of 2. If we don't have anything after it, like on the calculators, you don't have to close the parentheses. I kind of, for my brain, have to. But as long as you don't have like the minus over here, you're fine. You don't have to necessarily close them. Here it is going to be important that we close our parentheses. Because 2 natural log of 3 minus the natural log of 2. If I did not close this parentheses here, now I've changed that expression a lot because I have a natural log inside the natural log. So it is really important that we close the parentheses down here. If we have things after it, you gotta close them. Gotta. I have to make it nice and tidy in my brain and make things match up. And we get about 3.226.
Yep.
Okay. And we like to have the decimal answers if we need this for, like, how far am I going, how many years is it going to be, whatever. The decimal answers help us answer that. Also, if we need to check for something, that's when we would want the decimal answer. We have an exponential here, so we don't really have a problem. As long as our base and our argument aren't negative, we're good. And there is not a power I could put on either one of these that'll make them go negative. So our arguments are going to be positive with exponentials. Questions on those two? Okay. We're going to do a couple more log ones. So 2 shorter ones and then 1 big beastie. Got it. Cool. So looking at this guy here, what are we going to do? Yeah, switch this out of log form back to its exponential form. Absolutely right. If I have logs on only one side, we're going to have to switch it. So we're going to have our log base e, so we get e to our power of 5, which equals our 2x plus 6.
Would we subtract 6?
Yep. Solving means we're trying to get down to that x equals, so we're going to subtract our 6. So we're just going to have our e to the 5th minus 6 equals 2x. And then we divide. it's going to be a fraction, but that's okay. We can do fractions. E to the 5th minus 6 over 2. Technically, these are all numbers. So this is just like having 2 to the 5th minus 6 over 2. Or 7 to the 5th minus 6 over 2. It's just a number. It's not a pretty number. It's not a pleasant number, but it's a number. So we're going to type that one in the fraction or into the calculator too. Boop. So in the calculator, I'm going to put my e to the 5th, and it always kicks us up into that power, minus 6 over 2. Oh, except I made a mistake.
Yeah.
Those are in the exponent, and they should not be. Got to make sure that these are down here on that main line. If your 5 and minus 6 are at the same size on the top, you've got them both in exponents, so be real careful with that. It's very easy to make that mistake. I was zoomed in real far so I didn't see it.
I got 71.207.
Yep. About 71.207. So is that a valid solution or is that extraneous?
Valid.
That's valid. Because all we need to know is our base or our argument are negative. Our base is E, so that's cool. Our argument, positive 71, that's not going to be negative. We're cool. That's all we need to do to check. Make sure our base and our argument aren't negative. All right, on the right-hand side, what should we do here? Yes, we're going to condense this and we're going to take the addition into multiplication between the arguments. So we love the fact that all of our logs have that same base. They'll have base 7, super awesome. Crashing in the screen. But if I want to be able to say, oh great, I don't need them, I need to have just one log on each side. So we got to condense that right side down. So our left side's going to stay the same. We've got our log base 7 of 6x equals our log base 7 of 9 times our x minus 4. Oop, those blended together.
Do you have to put this, the multiplying dot, or
Nope.
is it okay?
No, yeah, if you just put it like that, totally fine.
Okay.
It means 100% the exact same thing. Now what are we going to do? Yeah, well, we'll distribute the 9 to the x minus 4. Yeah. We've got our log with the same base on either side, so I just need to know when these arguments equal each other. So we're going to set our arguments equal. So we can solve this by going that 6x equals, and I'm going to do this distribution, 9x minus 36. What are we going to do next? Yeah, absolutely valid. You can subtract the 9x. I know some of us will subtract the 6 and add the 36. That's absolutely okay. Just going to change your sign. So minusing 9x from both sides, we get that negative 3x equals negative 36. So what does x equal? 12. So is this a valid solution or is it extraneous?
Valid.
Valid. You're good on time. Questions on these two? Okay, so if you have the little sheet, that next one is all one problem. Big BC. So this is the last of our like pure equations we're doing for this chapter. Yeah, what? 2-story problems and then we're done. And they're short. So we have a whole bunch of logs up here. Log base b of x plus log base b of x minus 1 equals log base b of 2 plus log base b of x plus 14. And whenever we give you a log with a generic base like this, we get a little confuddled. Treat it like if it was a log base 2 or a log base 5, whatever we need to do. They're the same on both sides, so as long as we can condense things down, it doesn't really matter what that base is. We are trying to solve to get to an x equals, so we can condense this down to make this be way less gross. Because we have two different sides that we can condense down using our addition becomes multiplication. The product property for our logs. So I can rewrite this left-hand side, if I use a pen instead of a highlighter, as our log base b, and my arguments are going to multiply together. So we're going to have our x times that x minus 1. Gross. That's part of the reason I printed them, so that you didn't have to try and work the whole thing down, because it's gross. Log base b. Right-hand side, we can do the same thing. We can condense it down. We have our 2 times our x plus 14. So even just using those log properties, I've already taken this ginormous equation and shrunk it down to just 2 logs. Now I have the same log on either side of my equal sign. So it doesn't matter that we don't know what this base is. The base is the same on both sides. So we just need to know when our arguments equal each other. So we're going to take the fact that these logs have that same base and say, well, we don't need them then. We can just look at our arguments and figure out when the arguments equal each other. So we're going to set our x times x minus 1 equal to this thing. And I'm just going to distribute them at the same time. So we're going to have our x squared minus x equals 2x plus 28. What do we do next? Subtract the 2x and the 28, because I've got an x squared here. I've got a quadratic. We can try and solve this by factoring. So we're going to have our x squared. If I subtract 2x from both sides, we get minus 3x minus 28 equals 0. Huh? Yeah, they are. I don't know. I've had my door cracked because someone is supposed to come and observe the class today, but I think something happened, and that's okay. All right. What can we do to solve this? Factor it. Do we know a pair of numbers that's going to multiply to make negative 28 and add to make negative 3? Negative 7 and positive 4. So we can get this into the factored form of x minus 7 and x plus 4 equals 0. So what are our roots, our solutions? X equals 7 and x equals -4. Are both of those valid? No. Is the 7 valid?
Yes.
Yeah, totally cool. Is the -4 valid?
No.
No. These two cause us problems. They can't have a negative argument. -4 is the argument here. No bueno. Same thing here. So the -4 is extraneous, so the x equals 7 is our solution. That one's extraneous. So these ones that are like really long, I know they look real scary, and they look like, no thanks. We can do it, or not. That one, I think. Say that again? Oh, yeah. Yeah.
Is this the last test of the...
This and then the final. Yes. Okay. So we have 2 story problems to do on here. So the bottom 2. So we have here a town with a population that is growing continuously. What kind of equation are we going to use for something growing continuously? PERT. So that keyword for us is that continuously. Gives us our big clue on that one that we are going to use PERT. P-E to the R-T equals the amount we're looking at here. But they give us very little information. Pretty much they only give us the rate. So we know we're going to have some population that starts us out. We have E that's a number. What's our rate? 0.05. And we don't know time. That's what we're trying to solve for because it asks us how long. What's the time? And we want to know how long it's going to take for our population to triple. So if I start with 1 person, we'd be ending with 3 people. If I start with 10 people, we'd be ending with 30 people. So it's tripling. So if I start with P people and it triples, how many is that going to be? 3P. So even if they don't give us the population, we can use the fact that they're tripling to build our equation. So we know we've got a starting amount at P, and whatever that is should triple. And we want to try and figure out what T is. I'm just going to scooch this over so I have another extra line to work with. So how can I try and solve this for T?
Convert it to log form.
We do want to convert it to log form, but what should we do first? Divide by P. Get rid of the P. So if we divide both sides by P, we get 3 equals e to the 0.05 t. Now it usually looks a lot less scary. It's at least semi-familiar at this point. Because we see, oh wait, the thing I'm solving for is in the exponent, that means I need to switch forms. Because if I want to get t equals, I need to rewrite this. Log base e, also known as our ln of 3, 0.05 t.
Would we divide by 0.05?
Mm-hmm. Yeah, that's exactly what we're going to do. To get to our t equals, we're going to have our natural log of 3 divided by 0.05. That is technically a good answer. How long is that?
I don't know.
Written like that, I don't know. So to get the how much time, this is when we need our decimal answer. So to get the decimal answer, we type it in the calculator. So natural log of 3 over 0.05.
Are we still doing the 3 decimal places?
It's time, so it's like,
2.
we can do 2 or 3, it doesn't really matter. If it's money, we know it's going to be 2. Living creatures, whole numbers only. Time can be divided into relative numbers. Doesn't really make a diff. But 3 is totally fine. So to get our decimal form, we're going to have our natural log of 3 over 0.05. Boop. So it's going to take 21.972 years, or almost 22 years. That is pretty darn close to 22 years.
Okay. Label it.
21.972 years. Okay. I'm 21.9, so almost 22.
Oh, right. Oh, because it's not. I cut it off. I got it.
Yeah. It's not. It's not living creatures. We're looking at the time here. If it was the people, absolutely, whole numbers only. But it's time. Like I could do it half a day. I can do a part of a year. The next one, our last one for this, the last one for the chapter. Oh my gosh. And we got soda. Whoa. Mountain Dew. Holy cow, those are big words. I was apparently feeling elderly when I wrote this slide. So I made those words big. Must not have been wearing my glasses. All right, so a lot of times we get these kinds of problems and we go like, oh, that is a lot of stuff and it's very medicine-y. And we get a little scared. They give us an equation. So the caffeine spent time in Mountain Dew leaves your body for a healthy adult and approximately using this equation. 55, 1/2 to the T over 5. A is the amount of caffeine that's left in the body after T hours. We want to know how long until there's 10 milligrams of caffeine left. So we want to know when the amount in the body is 10. So where are we going to put that 10? A. How much caffeine did it start with? What was our initial amount? 55. That is in fact how much caffeine is in a Mountain Dew. But I was going to say,
Like you were probably drinking one when you were making this.
I have 3 answers.
You played live.
Totally does. Totally was. Either that or I was just thinking about one. That's a T. Boop. T. Okay, I'm going to change the view on this just a little bit so I don't have to do it sideways. There we go. So if we set our equation up like this, what should we do? Yeah, divide both sides by 55. Absolutely. So we're going to have 10 over 55. We can simplify that. They're both divisible by 5. 1/2 to the T over 5. Gross.
10 over 55 is
2 over 11. Yeah. So we can simplify that. 2 over 11 1/2 t over 5. So we have a lot of fractions going on here. I just simplified the 10 over 55. All we did here was simplify this fraction. So what should we do next? Yeah. So we're going to have log base 1/2. Hello, hello. Of what? What's our argument? Oh, I have a way better chair for you here. The backbreaker 3000. So our log base 1/2 of the 2 11ths, admittedly unpleasant, equals our power, t over 5. Ew, gross. Absolutely horrendous. Workable, but gross. Because I can't type that in the calculator. Ew. What are we going to need to use?
Change of base.
Using our change of base formula. So we're going to have to put this through as a fraction. Either common log or natural log. Does not matter which, just do not mix and match.
Multiply 5.
Yeah, we will. I'm just going to do change of base first. Change of base. Because this guy, well, technically a number. I got no clue. And we're trying to still figure out that time.
Can we do common log? We've been doing a
Yes.
lot of natural log.
That was exactly what I was going to do because we did natural log a couple of times, then we had a couple of problems that had natural logs in them. So we are going to use common log just to keep it different. If you use natural log every time, totally fine. It doesn't matter. What is going to be on the top one? The 2 11ths. The argument goes on the top. Base goes on the bottom. B bottom base. It's all about that base. No trouble. And this is admittedly horrendous. Gross. But we can get to a t equals. We're one step away. Multiply both sides by 5. So I'm just going to flip it a little bit just because. Log of 2 11ths over log of 1/2. Technically, we have found how much time it's going to take. Genuinely, we have no idea if that's going to be a second, an hour, or 5 years, or a million years. Who knows? So we type it in the calculator. Carefully.
I'm pretty sure caffeine doesn't stay in your body for a million years, but because you're probably dead by then. Yeah.
Probably. I didn't write down my fraction again. I'm good at this.
Miss B,
What's up?
guess what?
What's up?
I get to go see Hamilton on Sunday.
I get to go on Friday.
Yeah, Hamilton's in town.
The national tour.
Yeah.
Yeah.
I thought they weren't going to be in Indiana until next year because we're in Chicago. They're here now.
Mm-hmm.
If you download the app, the lottery's open. They're still doing lottery. Download the Hamilton app. There's lottery.
There's a Hamilton app?
Yeah.
Oh my gosh, I need it.
I told you guys, I can theater nerd with you till the day ends. Sports, I got nothing. So you don't have to put them in as fractions. You can put them in as decimals. You can put them in the calculator with the operator. 2 divided by 11. You can put them in as a fraction. You can put them in as a decimal. Still gonna work. It's gonna take 12.297 hours. Caffeine will hang around in your body for a while. That's why even if you have coffee in the morning, it can sometimes mess with your sleep. Youths, do not consume too much caffeine.
Says as she's drinking.
She says as drinking coffee. Exactly.
I didn't know.
I genuinely switched the page before picking a net. 12.297.
Wait, what part of India are they in?
Downtown.
Yeah.
Old National Center.
Yep.
All right. Have a great rest of your day. Tomorrow we'll be reviewing for the chapter test.
No, he's in Strawberry. He's not on the national. No, he's on Yeah.
Who are you talking about?
Leslie.
Oh, Leslie.